Hey everyone. Thank you so much for having me. Hi, kiddo. 3 times. I feel like I should have a punch card for a free Subway sandwich or something. I'm Kyler Middleton. I use the moniker Cloud Security Chick because senior principal architect is boring and doesn't mean anything. And this is a talk about adding something to the AzureRM provider because it's an open source tool. You are able to read and modify it when it doesn't do what you need. And this is the story of it not doing something that I need. I have a whole bunch of links here to this slide deck. It's based on a blog. I also publish, I'm at about 100 articles on how to do DevOps with lots of pictures and simple explanations. And I want everyone to do DevOps because I think it's fascinating. This is one of those things. So let's raise some hands. This is going to be interactive because I want to entertain my 3-year-old. So how many times have you had this conversation where you say, hey, please, operations, please secure this resource? And ops says, you know, Terraform doesn't do that. Our tools can't do that yet. Anybody? Just me? There's a couple. And this is a really common conversation because these tools are changing, clouds are changing, stuff changes really fast. And so I asked Dolly to create a reference for that conversation, and this is what we got. So I'm sure all of us are wearing our, AI bulletproof vests, and we have our TLS lock on our belt, right? Everybody, right? I thought this was a security conference. This specific project was that our firewalls, our firewall policy actually in Azure, needs to know all the IP groups, all of them, everywhere. And they change all the time. We have a threat feed of bad IP groups. Those change all the time. We have IP groups that we construct that represent geolocations like the United States and India. And there's about 130,000 of those IPs. And when you slice and dice them every 5K, because that's all that an IP group can handle, you end up with 22 groups that represent the United States and 3 that represent India, and a lot of them that are built by our threat feed data for bad stuff, bad blocks that need to be blocked. And so we asked our operations team, which is often me asking myself, to build this. And the answer was, Terraform can't do that. It can find one IP group at a time. So what do we do? What do you do when your tools fail? So we could do it by hand. We could go into our Terraform and do a pull request by hand every time there's a new bad IP group or anytime there are new IPs assigned to the United States or India that go over that 5,000 threshold. So it creates a new one or removes one. But that's forever work. And it might not even be less automation because you still need something to alert you when those threat feeds have updated and created a new IP group, right? So we might be building custom automation to tell the humans to do the thing that the automation could just do in the first place. So I hate that idea. I don't want to do that. We could update our CI with something bespoke. We could add some steps for the Azure CLI to go find them and use the name substring and write them to a CSV and then import that with Terraform. That's totally possible, but it's bespoke and it's fragile and it would probably end up just breaking and then we'd have to go do it by hand anyway. So in conclusion, yuck. None of those solutions sound like something we want to do. So the solution that this is for Kennedy. I have some cartoons here. Can we fix it? Thank you. You're all wonderful. So first of all, what's a Terraform? Why are we talking about changing a Terraform and what is a Terraform? Terraform, let's do hands again. Who is familiar with Terraform? It's got to be a lot, right? Yeah, totally. Terraform has taken over. It's the infrastructure as code tooling that has won the king of the hill. It is used to manage, which means create, read, update, delete, all the CRUD stuff, all of your resources across all of your platforms, including AWS and Azure and GCP and all the other acronyms that I can't think of right now. And it's fantastic. It's had some licensing changes, but the providers that it uses, which are basically translation libraries, think like the Babelfish for AWS, the Babelfish for Azure, are totally open source, and you can totally go add stuff to them. So here's an example of what it looks like in the top left. Let's see if my laser works, kinda. In the top left, you've got what Terraform code looks like, and it's really simple. It's declarative. Your operations team is very familiar with it, and I bet a lot of you in this room are too. It's pretty easy to figure out what's going on, which is that we are doing a data call to identify a bunch of IP groups that live in a resource group. Super simple. We're outputting their IDs. We're outputting their names using just the dot attributes. Super simple. In the bottom right is Go, which is what this is doing on the back end. And it's not nearly as easy to read. Go is very powerful. It's extraordinarily useful, but it's not nearly as declarative and simple and easy for your ops teams to understand. So we're first of all declaring some slices of strings of maps, and then we're iterating through them to read all the values and then doing a filter string contains and adding them to the slices and then eventually outputting them. And it's just really a lot harder for your ops teams to understand, probably. And I imagine most of the folks, does anyone here work with Go? Like, is that something y'all use regularly? I see a couple of hands, but it's not the same as Terraform, right? It's just not the same. So this is coming. A lot of the tooling that you're familiar with are written in Go. I think I have a list here somewhere near the end, but it's Kubernetes, it's all sorts of tools. So Go is coming, it's useful. You should be encouraging your teams to understand what's going on. So we're going to go through the Go because we want to do something. We want to upgrade Terraform. Let's supercharge it. So section number 1 of a data resource, really all resources, but we're just going to do data because it's the simplest ones. It just has to do read operations, is the grouping. And this is network because it's an IP group. It's firewalls, super simple. And this is all the imports. Interestingly, you have to import time and location and tags, and you can see IP groups there. And then you have your main function, which basically handles the IO for the resource, for changes, for CRUD operations. So reading, modifying, creating, deleting, whatever. This is the primary one. It has child resources, like Kennedy back in the back, that do stuff. Like if you want to read something, there is a child function that is utilized to do something. And there's a whole bunch of Go on here. Don't feel like you need to understand any of it, but there are lots of child functions, particularly in real resource definitions, because you need to do the whole CRUD lifecycle. In data, you just do read. So there's one child, and that's what it does. You'll notice that we're calling a function that uses sort of this camel case data source IP group, and not the snake case Azure IP group. And that's because there's a mapping within Terraform called the registration.go, this one specifically for the network functions, and it translates that. You can see down at the bottom is Azure IP group is translated to the function call data source IP group. And if you don't add that, it won't work. Ask me how I know. And it's imports all the way down, which is very different than how I'm familiar with working with Bash and sometimes Python. You can just do stuff directly because you get a bunch of things for free, but Go is not that way. And these Terraform providers are not built that way either. So Azure IP groups import a client, which imports a client, which imports a function, which imports a function that can read IP groups by resource. And finding that took about 3 hours, because it was new to me, but also because just calling functions is just a Russian nesting doll of dependencies. But we did find one that can list IP groups by resource group. So the backend, the library that we're using, the basic SDK that underpins Go, can do this. So Terraform probably can. We can teach it how, because it already knows how, probably. I just have to learn how personally. So it will return all the IP group information within a resource group. So first of all, let's copy the Smart Kids homework. I'm a huge proponent of stealing. Definitely steal. Very recommended. Copy all the smart stuff that other people have built before you, because there's a lot of smart stuff you can steal and look smart yourself. So my contribution is to add the S, and then we're done. Not really, but the files are there, and that's a good start. So let's write a plural data source. So this is all basically the exact same. We're still in the network package. We need a couple of extra things like slices and strings because we're going to modify some data as we go. Visual Studio Code adds this all for you. So I don't care. You shouldn't care. It gets added at the top when you call these functions. The main function, again, we just added an S, not very complicated. And the line 21 there that's highlighted is the first CRUD operation, and data calls only have one. They just have read. And it calls that child function data source IP groups read. There's some other stuff down below that's the schema for this data source for this resource that's populated and returned when Go runs it. We'll talk about that a little bit more later. This is that. Exactly what we talked about. So this is part of the attributes that are populated. Populated is a really specific word here that is represented by computed. So computed is a flag in Terraform core, the core binary, that says this is going to be populated by the automation, by the process that builds this resource. It's not something that you can send, and if you try, it's going to fail. And you can see that it is a list, and each element is a type string, because we're going to be returning a whole bunch of IDs or a whole bunch of names. And that's something that I added for this resource. There's favorite and only child, again, hey Kennedy, that it's calling, which is the read operation. And you can see it's doing a bunch of stuff, and this is very esoteric. It's building a client that's going to handle the IO with the provider. It's finding the subscription ID from the client metadata, which is just something that you pass in with the default provider when you build stuff. And it's passed down to this function from the core binary. And then we look at the ID that's going to be used later to assign to it. ID is really interesting. I looked up all of our IP groups and returned all that information exactly appropriately, and it wouldn't work. And I spent 3 hours figuring this out until a helpful senior said, if you don't assign an ID to the resource, even though this is data and there is no resource, it's not populated in your Terraform state file and it's not used at all. Terraform validates that. So you have to add an ID, even if it's a data call. There's only one data call that you should ever do for a resource group, because for this IP groups read function. So we just use that. This is the tiniest bit of code that goes and gets all of them. And it's because it's calling the function that calls the function that calls the function. But basically we're saying store the response and also the error, if there is one, by using the client, by listing the list by resource groups. And if there's an error, print it. We store it and filter it. So basically we assign a name and ID slice of strings, which is just a list of strings in Go terminology. And then we filter through all of them and check if they contain the name substring, because you probably want to filter them, right? You don't want to get all of your IP groups. You want to find them and not have to call regex in Terraform. And then we append them to the slice if they match. Oh, and notably, I'll go back if I can, I added a whole bunch of comments to this code, and it was accepted and merged, and I was so proud because I couldn't find any comments across this whole provider. And then about 6 weeks later, someone removed them, which seems rude. It's just making it harder for someone down the line and harder for me to remember because I have a goldfish memory. Maybe I'll go back and add them in. And I found out that it worked, which was so cool, but it didn't alphabetize them, which made me crazy and my eyes started twitching. So I found out you can sort them. So in this function call, it returns alphabetized names and IDs, because why wouldn't you, right? We pass the info to the caller data structure. So on line 82, that's the thing that I was missing. You need to set an ID and pass it to the D, which is the data construct for this resource. Even though it doesn't have an ID, it needs an ID. Doesn't make any sense. And then you set the names and you set the IDs. And if it has trouble doing them, print out the error messages, and then you return nil. And if we've gotten to this point, we have exercised all of the edge cases that could possibly have gone wrong, at least, so far that I can imagine. And it did not fail. So we return nil, set the error to none, and it should work, right? But how do you know? It looks right. It'll probably work. It works on my machine, right? But we need to make sure that it actually works. So you can write these testing functions that are able to call stuff. And this one, for example, says to use a data call, our new one that we're constructing, and find an IP group here. And this stuff is all built here, which is just sample resource group. You can see we're building some sort of randomized account test route group in a specific location and blah, 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 blah. And all of this is really basic stuff. And all of this didn't work because I forgot, I'll use this again. This depends on, when you run Terraform in your console, it prints out error messages. It's very verbose, which is really helpful when you do dumb stuff, which we all do all the time, right? It doesn't when you run the testing library. So it was just failing because it runs all of this stuff immediately at the same time concurrently. So it was trying to find this group that it has to build with this data call that runs very fast because it's not building anything at the exact same time. And it was failing every time, even though my code was perfect. And I started to suspect that compiler errors and Go was broken, and it really was just me. And I needed to put a depends on so it would wait for it to be built before it would go. This testing is all really cool. It's very different than writing something in simple utility shell scripting language like Bash or Python, because you can just run those commands in your terminal. Go is not like that at all because it's a compiled language. So you have to write these testing unit tests because it has to find all the dependencies and build a binary and then execute the binary and see what happens. And so that's just very different for me to learn how to do this. I hope this will help you get there if your teams want to do this. I have blogs and recordings and all this stuff. And that's what it's building. And then this is the actual function call that says like, hey, run that test and then check the outputs. And you can see down on line 39 and 40, check to make sure that there is an ID and there is a name. And this is a unit test that just exactly matches one of the IP groups. There's no substring matching to find 5 of them. It's just finding one. And it should find one ID, one name. And if it does, it works. And that test passed. I only ran it 50 times, but this is the one where it says that it actually did pass. It worked. Yay. I wrote a couple of other unit tests, I think here. Yep, we can see there's no results where we want to find 0. There's a single that's an exact match success. And there's multiple where there's like 3 IP groups and we want to find all 3 of them and find exactly 3 IDs and 3 names. And this took, you can see it takes a while to compile and run. This takes a couple of minutes, but it did pass. These actually build resources. So if you're building firewalls, like I think I have a $25 bill because I'm working on firewalls next, because it's actually building a firewall and testing it. So here it's building IP groups, which cost very little. Thankfully, I don't have a cost from this one other than time. And testing all of it for real in the real environment. We want to, so we're done now. Again, except we're not. There was a lot of times when I was like, I'm finished. And then it's like, oh yeah, I have one more thing to do. This is one of those things. We're not actually running it ourselves, right? We're running a testing suite. We're running a unit test in isolation. So how do you know that it worked? You kind of don't. So let's do that. So you do make build, which actually compiles the entire provider. And it looks like here it took 300 seconds. So something like 5 minutes on a very modern M2 MacBook Pro. And so if you're on an older computer, it will take a really long time. 15, 20, 30 minutes is pretty normal for it to build a provider. And if you have to tweak something and then wait 30 minutes, it's definitely time for a coffee break. It puts it into your Go path as a binary, like a local compiled binary. It's not, uploaded to the registry or anything like that. And then you have to tell Terraform. I think this is a .terraform RC in your home directory to go find that local binary. Don't use the one on the internet. Use the local one that might be broken. And then you run it. This is just a really simple, reductive thing, example code of like, this is actual Terraform that you actually run and you see whether it works. And this is it actually working. You can see at the top that the text is a little small for the folks in the back. It says, I'm using the local provider, FYI. If it breaks, it's your fault. And down at the bottom, we can see it's reading. It's using our new IP groups thing that we wanted. It's printing out all the IDs and all the names, and they're alphabetized, so my eye's not twitching, and it works. Yay, that thing actually works. This is still local to my computer. We haven't done a pull request yet. Remember to share your toys, Kennedy. And so for the provider repo, you basically fork it and then make your changes because you don't have the ability to make commits or create branches on the provider. Even though it's open source, you still have to play with your toys in your own sandbox. And then you change all the code there. Don't make my mistake where you make all the changes and then you can't push your commits because you don't have rights. I had to make all the changes many times. And we also added a README to tell people how to use this. This usually, since the new resource, all of those are bundled with the same PR and then released. And the PR address is down there at the bottom, 25540. Should you encourage your, well, before we move on, it worked. It took about a week for it to get reviewed and me to make requested changes, and it was released a couple of months ago. So you can now find multiple IP groups if you need to. It took about 2 days of me being like a senior-ish DevOps engineer to get that done. So if you need something that Terraform cannot do, it's totally possible. You can encourage your ops teams and they can do it. Should you encourage your ops teams to contribute to open source projects to learn Go? Yeah, absolutely. It seems to be that this is the lingua franca of operations tools. So Kubernetes, Docker, Istio Mesh, Prometheus, Argo CD, Etsy database. I am sure you all are familiar with most or all of these tools. They're all written in Go. So if you want to go down to the source code and figure out how does this tool work? Can we make changes to it? Can I add this thing? Your team's got to learn Go, or you have to learn Go. And that's it. I think I talked really, really fast, but that's how we added functionality to the provider. You can find more on letsdodevops.com. I also host this podcast called Day 2 DevOps, and you can hear more from me. But I would love to hear some questions from the audience. I think we hopefully have some, unless I talk too fast.